Now in this lecture we find out the length of line segment X. In the drawing we have a regular hexagon. This is a regular hexagon. Actually an hexagon is a polygon that has 6 equal sides and 6 equal angles. That is to say, all the sides of the polygon are equal to each other, and all the 6 angles of this hexagon polygon are equal to each other. So we know that AB equals to 2 units, PB equals to 3 units, and our mission is to find out the length of line segment PA that is equal to X, or to find out the value of X. So because of the fact that this is a polygon hexagon, this is a regular hexagon, you know that all the sides this regular hexagon are equal to each other. But one side, AB equals to 2 units, therefore all the other sides must be also equal to 2 units. That is to say, side BC equals to 2 units, side DC equals to 2 units, side ED equals to 2 units, side FE equals to 2 units, and side FA equals to 2 units. And all the angles inside a regular hexagon are equal to each other, or all the interior angles of the regular hexagon are equal to each other. First of all, what is the sum of the angles in a regular hexagon? So if we have a regular hexagon, so this is a regular hexagon, A, B, C, D, E, F. What is the sum of the angles in this regular hexagon? The sum of those 6 angles. In order to find out, we will join points B and E together by a straight line. By joining points B and E, we created here 2 quadrilaterals. Quadrilateral ABFE and quadrilateral BCED. We know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in quadrilateral ABFE equals to 360 degrees. Likewise, the sum of the angles in quadrilateral BCED, this quadrilateral, is also equal to 360 degrees. And therefore, the sum of the angles in this regular hexagon must be equal to the sum of the angles of the 2 quadrilaterals, that is 360 degrees plus 360 degrees, that is actually 720 degrees. So I found out that the sum of the angles in any regular hexagon is equal to 360 degrees. All the sides of this regular hexagon are equal to each other, and all the angles are equal to each other. This regular hexagon has 6 angles, 1, 2, 3, 4, 5, 6, and all of them are equal to each other. If the total angles of this polygon, of this regular hexagon, it is equal to 360 degrees, and it has in total 6 angles, therefore the size of one angle, and they are equal to each other, therefore the size of one angle must be equal to 370 degrees over 6, that is 120 degrees. So we found out that all the angles of the regular hexagon are equal to each other, and each of them is equal to 120 degrees. So actually this angle equals to 120 degrees. This angle equals to 120 degrees. This angle equals to 120 degrees. This angle is also equals to 120 degrees. This angle equals to 120 degrees, and this angle is also equals to 120 degrees. Okay. In the next step, we'll extend side DC of this regular hexagon by a straight line. This point is point L, and what is the size of this angle? First of all, DC is one side of the regular hexagon. As a side of a regular hexagon, it is absolutely a straight line. DC is a straight line, and when we extended the straight line DC by a straight line, the result must be a straight line, because when you extend a straight line by a straight line, the result must be a straight line. So DL, it is also a straight line. DL is a straight line, so if we focus on this side of the straight line DL at point C, this is point C. So if we focus on this side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at this side of the straight line DL at point C? We have this angle that is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 1. So this missing angle must be equal to 60 degrees. In order to complete the sum of the angles on this side of the straight line DL at point C to 180 degrees, the missing angle must be equal to 60 degrees. Okay? In the next step, from point B, we will draw perpendicular on DL. From point B, we will draw perpendicular on DL. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DL as M. By doing this construction, we created the right triangle PBM. Or actually, we have here this right triangle that is CBM. The small right triangle is CBM. Okay, so I'll copy the small right triangle CBM and we'll analyze it. So this is the right triangle CBM that I copied from the original drawing. In this right triangle CBM, this angle equals to 60 degrees according to what we already found out. So in the right triangle CBM, cosine 60 degrees equals to CM over CB. CM over CB. Cosine 60 degrees equals to CM is the missing line segment over CB. CB equals to 2 units according to what is given as the question. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2. It is equal to Cm over 2. Here we will multiply this equation by 2 and we will get that Cm equals to 2 over 2, that is 1. So we found out that Cm equals to 1 unit. You can write here that Cm equals to 1 unit in its length. Likewise, cosine sinus 60 degrees in the right triangle CMB equals to BM over CB. Sinus 60 degrees is square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2, and it is equal to BM. BM, it is the missing line segment, so we leave it as it is, over CB. But it is given as the question that CB equals to 2, so therefore we substitute CB by 2. Here we will multiply this equation by 2, and we will get that BM equals to the square root of 3 units. BM equals to the square root of 3 units. Okay. BM equals to the square root of 3 units. We write in the original drawing that BM equals to the square root of 3 units. In the next step, we will focus on the right triangle, triangle PBM. PC is the missing line segment, so we will define the length of PC as A, and therefore PM in total it is equal, PM equals to PC plus CM. PM equals to PC plus CM, that is to say it is equal to A plus 1. So I will copy the right triangle PMB in a new page and we'll analyze triangle PMB. PM equals to A plus 1, BM equals to the square root of 3 units, and the hypotenuse PB equals to 3 units. This again equals 90 degrees according to our construction. So this is the right triangle, triangle PMB that I copied from the original drawing. So here we will implement the Pythagoras theorem in order to find out the value of A. Here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The hypotenuse in the right triangle PMB is PB, therefore the square of the hypotenuse is PB squared. And it must be equal to the sum of the sides of the perpendiculars, that is to say, it must be equal to PM squared plus MB squared. Okay, so PB squared, PB is 3, therefore PB squared is 3 squared, that is 9, and it is equal to PM squared. PA is A plus 1, therefore PM squared is A plus 1 squared plus MB squared. MB equals to the square root of 3 units, therefore MB squared is the square root of 3 squared. In conclusion, according to the Pythagoras theorem, we found out that 9 equals to a plus 1 square plus square root of 3 square. So 9 equals to a plus 1 square plus the square root of 3 square is 3. So here we subtract 3 from this equation and we get that 9 minus 3 is 6. So 6 equals to a plus 1 square. Here we'll take a root out of this equation and we'll get that the square root of 6 equals to a plus 1. Okay, here we'll subtract 1 from this equation and we'll get that a equals to the square root of 6 minus 1 units. Okay, so we found out the value of a. You can write here in the original drawing that a equals to the square root of 6 minus 1 units. In the next step, we'll join points A and C together by a straight line. By joining points A and C, we created a triangle ABC. Okay. So I will copy this triangle ABC in a new page and we'll implement here the law of cosines. As I already mentioned before, all the angles in this regular hexagon are equal to each other and each of them is equal to 180 degrees. So this angle is one out of 6 angles of the regular hexagon. That is to say it is equal to 120 degrees. So triangle ABC copy triangle ABC in a new page and we implement in this triangle the law of cosines. So actually, this is triangle ABC that I copied from the original drawing. This angle equals to 120 degrees, and can I see ABC equals to 120 degrees, AB equals to 2 units, BC it is also equals to 2 units. Okay, it is equal to 2 units. Okay. We want to find out the length of side AC. Here we implement the Pythagoras theorem in the triangle ABC. We will remind you what is the law of cosines. The law of cosines is true in any triangle. So this is triangle MNF. The length of MF is A units, MN equals to B units in its length, and FN equals to C units in its length. And this angle, it is angle theta. According to the law of cosines, c square, c is the length of Fn, side Fn, c square equals to a square plus b square minus 2 times a times b times cosine theta. And this rule can be implemented in any triangle. So we implement this rule in our triangle ABC. According to the law of cosines, we get that AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. This equation is the implementation of the law of cosines in the triangle ABC. So AC squared equals to AB squared. AB is 2, so AB squared is 2 squared, it is 4, plus BC squared. BC is 2, so BC squared is 2 squared, it is 4 also, minus 2 times AB is 2, and BC it is also 2, times cosine 120 degrees. Cosine 120 degrees equals to minus 1/2. Okay, so actually found out that AC squared equals to 4 plus 4 is 8, and here minus times minus is plus, so this expression in total will be a positive expression. And you have here 2 over 2 is 1, so in conclusion we have here 2 times 2, that is 4, so it is 8 plus 4. 8 plus 4 is 12. So we actually found out that AC squared equals to 12 units. We substitute 12 by 4 times 3, so AC squared equals to 4 times 3. Here we'll take a root out of this equation and we'll get that AC equals to the square root of 4 times 3. So here we'll take 4 out of the root and we'll get that AC equals to the square root of 4 is 2. Inside the root we left only with 3. In conclusion, we found out that AC equals to 2 times 3 units. 2 times 3 units. Here, AC equals to 2 times 3 units. So here, AC equals to 2 times 3 units. Okay, so what is the size of this angle ACB? I copy the right triangle ABC again and we'll analyze it. So this is triangle ABC, the copy from the original drawing. In triangle ABC, we know that side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. But we also know that in front of equal sides in the triangle there are equal angles. So those 2 angles that are located in front the equal sides, AB and BC, must be equal to each other. So if one angle is x, then the other angle must be also equal to x. Okay. This is triangle ABC. We note that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC, the sum of its angles must be equal to 180 degrees. So x plus x plus 120 degrees must be equal to, in total, to 180 degrees. Here we subtract 120 degrees from this equation, and we get that x plus x, that is 2x, equals to 180 degrees minus 120 degrees, it is 60 degrees. 2x equals to 60 degrees. We will divide this equation by 2, and we will get that x equals to 60 degrees over 2, that is 30 degrees. So if I know that this angle equals to 30 degrees, and this angle is also equal to 30 degrees. So that is to say, this angle ACB equals to 30 degrees. And what is the size of angle ACP, this angle? Actually, for drawing, you can say that the big angle, this angle that is equal to 120 degrees, that is actually angle PCB, minus the small angle that is actually angle ACB, is equal to this angle that is actually angle ACP. Repeat again. The big angle PCB that is equal to 120 degrees minus the small angle that is angle ACB that is equal to 30 degrees, it is equal to there is an angle ACP. So angle PCB equals to 120 degrees minus angle ACB that is equal to 30 degrees, it is equal to angle ACP. The size of angle ACP. So angle ACP equals to 120 degrees minus 30 degrees, it is 90 degrees. So if I know that angle ACP, it is a right angle. This angle ACP, this angle ACP equals to 90 degrees. And because of the fact that angle ACP equals to 90 degrees, therefore triangle ACP, it is a right triangle. So I'll copy the right triangle in a new page, and we'll implement in the right triangle, triangle ACP, the Pythagoras theorem. So actually, this is the right triangle, triangle ACP, that I copied from the original drawing. In this triangle, triangle ACP equals to, this angle equals to 90 degrees, angle ACP. Side AC equals to 2 times square root of 3 units, and side BC that is equal to A equals to the square root of 6 minus 1 units. And we find out the length of the hypotenuse AP that is equal to x by implementing in this triangle the Pythagoras theorem. So here my PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle APC is AP, therefore the square of the hypotenuse is AP squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC squared plus AC squared. AP equals to x, therefore AP squared is x squared. X is the line segment that we are looking for in this question. And it is equal to PC squared. PC equals to the square root of 6 minus 1 unit. Therefore, PC square will be equal to the square root of 6 minus 1 square plus AC square. AC equals to 2 times square root of 3. Therefore, AC square equals to 2 times square root of 3 square. So in conclusion, we found out that x square equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. So x square equals to, we'll open the brackets here according to the algebraic identity, that a minus b square equals to a square plus b square minus 2 times ab. Here a is the square root of 6 units and b is 1. So square root of 6 minus 1 square equals to the square root of 6 squared, that is 6, plus 1 squared, that is 1, minus 2 times square root of 6 times 1, plus 2 times square root of 3 square. 2 square is 4 and square root of 3 square is 3. So 4 times 3 is 12. So in conclusion, this in total this expression equals to 12. So we found out that x squared equals to 6 plus 1 is 7 minus 2 times square root of 6 plus 12. So x squared equals to 7 plus 12 is 19 minus 2 times square root of 6 units. Here we take a root out of this equation and we will get that x, the line segment that we are looking for in this question, equals to the square root of 19 minus 2 times square root of 6 units. So in terms of numbers, it is equals to 3.755 units. So we finished to answer to this question. Here we found out that there is a line segment, the line segment that we are looking for here, x, AP that is equal to x, it is equal to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, it is equal to 3.755 units. In the next step, I will summarize the lecture. Okay. So, in the drawing, we have a regular hexagon. A regular hexagon is a polygon with 6 sides, with 6 straight sides. All the sides of a regular hexagon are equal to each other, and all of its 6 angles are also equal to each other. It is given as the question that side AB equals to 2 units, therefore all the other sides of this regular hexagon must be also equal to 2 units. All the 5 sides, the other 5 sides. Here we know that line segment PB equals to 3 units in its length. And I repeat again that all the angles inside this, all the 6 angles inside this, or the interior angles, all the 6 interior angles of this regular hexagon, they are equal to each other, and all the sides are equal to each other. Our mission is to find out the length of line segment AP that is equal to x, to find out the value of x. Okay, so first of all, we have to find out the sum of the angles in any regular polygon or regular hexagon. So this is a regular hexagon, A, B, C, D, E, F. In order to find out the sum of the angles in this regular hexagon, we joined points B and E together by a straight line. By joining points B and E, we created here 2 quadrilaterals. Quadrilateral A, B, F, E, this quadrilateral, and quadrilateral B, C, E, D. Okay. We have already know then the sum of the angles in any quadrilateral is equal to 360 degrees. That is to say, the sum of the angles in this quadrilateral ABFE equals to 360 degrees, and the sum of the angles in this quadrilateral BCED also equals to 360 degrees. Therefore, the sum of the angles in this regular hexagon will be equal to the sum of the angles on those two quadrilaterals. That is actually 360 degrees plus 360 degrees, that is 720 degrees. So we found out that the sum of the angles in any regular hexagon, it is equal to 720 degrees. And because of the fact that all the 6 angles here are equal to each other, and we know that the sum of all angles in total, they are equal to 720 degrees. And this regular hexagon has 6 angles and they are equal to each other. Therefore, the size of one angle must be equal to 720 degrees divided by the total angles, that is 6. 720 degrees over 6 is 120 degrees. So we found out that each of the 6 angles of this regular hexagon, it is equal to 120 degrees. So here actually all the angles, all the 6 angles here are equal to 120 degrees each of them. Okay. In the next step, we actually extended side DC by straight line until point L. DC is one side of the regular hexagon, therefore as a side of regular hexagon it is absolutely a straight line. We extended the straight line DC by straight line. When we extend the straight line by straight line, the result is a straight line. So DL, it is also a straight line. So DL is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line DL, at point C, the sum of the angles at this side of DL at point C must be equal to 180 degrees according to rule number 1 that I mentioned here. So which angles we have at this side of the straight line DL at point C? We have this angle that is equal to 120 degrees plus the missing angle. In total, it must be equal to 180 degrees. Therefore, the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on this side of DL, point C to 180 degrees, the missing angle must be equal to 60 degrees. So this angle BCM equals to 60 degrees. Okay. Then from point B, I go perpendicular on DL. From point B, I go perpendicular on DL. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DL as M. Okay. By doing this construction, we actually created here the right triangle BMC. So I copied the right triangle BMC and then we analyze this right triangle. I copied it in a new print here. This is the right triangle BMC or CBM, as I copied from the original drawing. This angle equals to 90 degrees according to our construction. This angle equals to 60 degrees according to rule number 1. The side BC equals to 2 units according to what is given us the question. In this right triangle CBM, cosine 60 degrees equals to CM over BC or CB. So cosine 60 degrees equals to CM over CB. CB is 2 units, so we substitute CB by 2. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2. In conclusion, we found out that 1/2 equals to Cm over 2. Here we multiply this equation by 2, and we found out that Cm equals to 1 unit. Here, the side Cm equals to 1 unit. Likewise, then we know that sinus 60 degrees equals to MB over BC. Sine of 60 degrees equals to BM over CB. Sine of 60 degrees equals to BM or MB over CB or BC. Doesn't matter. So sine of 60 degrees equals to BM over CB. Sine of 60 degrees is square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2, and it is equal to BM. BM is the missing line segment, so we leave it as it is, over CB. CB is 2, so we substitute CB by 2. In conclusion, we found out that square root of 3 over 2 equals to BM over 2. Here we multiply this equation by 2, and we found out that BM equals to the square root of 3 units. So sine BM equals to the square root of 3 units. So in conclusion, we found out that CM equals to 1 unit, and BM equals to the square root of 3 units. Okay? Then we focused on the right triangle, triangle MPB. This right triangle, triangle MPB. So I copied the right triangle MPB in a new page, and we analyze this right triangle MPB. CM equals to 1 unit. PC is the missing line segment, so we defined PC as A. And therefore PM equals to PC plus CM. That is actually A plus 1. Okay, PM equals to A plus 1. BM equals to the square root of 3 units. And the hypotenuse PB equals to 3 units. We will implement the Pythagoras theorem on this right triangle in order to find out the value of A. So this is the right triangle PBM that I copied from the original drawing. As I already mentioned before, PM equals to A plus 1, BM equals to the square root of 3 units, and the hypotenuse BB equals to 3 units. Here we implemented the Pythagoras theorem on this right triangle PBM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle PMB is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM square plus BM square, or MB square. So PB equals to 3 units, therefore PB square is 3 squared, that is 9. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to PM square plus MB square. PM equals to A plus 1, therefore PM square is A plus 1 square, plus BM square. BM is square root of 3, therefore BM square, or MB square equals to the square root of 3 square. In conclusion, found out that 9 equals to A plus 1 square plus square root of 3 square. So 9 equals to A plus 1 square, and the square root of 3 square, it is actually, of course, equals to 3. Because it is two operations that are opposite to each other, therefore they cancel each other, and we left only with 3. Here we subtracted 3 from this equation, and we found out that 9 minus 3 is 6, so 6 equals to A plus 1 square. Here we took a root out of this equation and found out that square root of 6 equals to A plus 1. Here we subtracted 1 from this equation and found out that A equals to the square root of 6 minus 1 units. So we found out that A, the missing line segment PC, that is equal to X, it is equal to square root of 6 minus 1 units. Okay, so in the next step, we join points A and C together by a straight line. By joining points A and C, we created here triangle ACB. Angle ABC, this angle equals to 180 degrees because it is one out of 6 angles of the regular hexagon, and we know that all the angles of the regular hexagon, they are equal to 120 degrees. Therefore, this angle is one out of 6 angles of the regular hexagon that is also equals to 120 degrees. Okay? We know that AB equals to 2 units and BC also equals to 2 units. So this is actually the right triangle ABC that I copied from the original drawing. I repeat again that AB equals to 2 units, BC equals to 2 units also, and this angle ABC equals to 120 degrees. We implemented in this right triangle the law of cosines in order to find out the length of the AC, of side AC. The law of cosines is true in any triangle. I will remind you what is the law of cosines. If we have triangle MFN, that could be any triangle. The length of FM is A units, side MN equals to B units in its length, and side FN equals to C units in its length, and this angle FMN equals to theta. Then according to the law of cosines, c squared equals to a squared plus b squared minus 2 times a times b times cosine theta. This the law of cosines is in any triangle. So we can implement the law of cosines in triangle ABC in order to find out the length of AC. So according to the law of cosines, AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. So AC squared equals to AB squared. AB equals to 2, therefore AB squared is 2 squared, that is 4. Plus BC squared. BC is 2, so BC squared is 2 squared, that is also 4. Minus 2 times AB, that is 2, times BC, that is also 2. And cosine 120 degrees is equal to minus 1/2. So we substitute cosine 120 degrees by minus 1/2. So this expression we have minus times minus, that is plus. So this expression will be a positive number. And we have here 2 times 2, that is 4, and 2 in the numerator and 2 in the denominator that cancel each other. So we left only with 4. In conclusion, we found out that AC squared equals to 4 plus 4 plus 4. That is actually 8 plus 4, that is 12. So AC squared equals to 12. We substituted 12 by 4 times 3, so AC squared equals to 4 times 3. Then we took a root out of this equation and found out that AC equals to the square root of 4 times 3 units. Okay? The square root of 4 is 2, so we can take out 4, we can take 4 out of the root. And we will get that AC equals to 2. Inside the root we left only with 3. So AC equals to 2 times square root of 3 units. Inside AC equals to 2 times square root of 3 units. You can write here in the original drawing that AC equals to 2 times square root of 3 units. Okay? Then I will focus again in triangle ABC. I copy triangle ABC in this page. This angle equals to 120 degrees. Because of the fact that side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides AB and BC must be equal to each other. So if one angle is x, then the other angle must be also equal to x. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC. So the sum of the angles in this triangle is x plus 120 degrees. It must be equal to 180 degrees. Again, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. X plus x is 2x. So 2x plus 120 degrees equals to 180 degrees. Here we subtracted 120 degrees from this equation and found out that 2x equals to 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees. Here we divided this equation by 2 and found out that x equals to 30 degrees. So those two angles are equal to 30 degrees each of them. So here angle ACB equals to 30 degrees. And angle PCB equals to 120 degrees. Therefore, the missing angle will be equal to 120 degrees minus 30 degrees. I'll repeat again. The big angle PCB minus the small angle ACB is equal to 30 degrees must be equal to the missing angle ACP. So angle PCB is 120 degrees, angle ACB is 30 degrees, therefore the missing angle equals to 120 degrees minus 30 degrees, that is 90 degrees. So we found out that this missing angle it is equal to 90 degrees. That is to say it is a right angle. And because of the fact that angle PCA, this angle, it is a right angle, therefore the green triangle, triangle APC is a right triangle. So I copied the right triangle APC in a new page and we implemented here the Pythagoras theorem. This is the right triangle, triangle APC, that I copied from the original drawing. AP is x, it is the line segment that we are looking for. This angle equals to 90 degrees according to what we have already found out. we have already found out that AC equals to 2 times square root of 3 units, and PC equals to square root of 6 minus 1 units. And the only missing side is the hypotenuse AP that is equal to x. So we'll implement here the Pythagoras theorem in order to find out the length of the hypotenuse AP that is equal to x. And that is actually the answer to our question. We have to find out the length of x. So according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle APC is AP, therefore the square of the hypotenuse is AP squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC squared plus AC squared. So AP is x, therefore AP squared is x squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC squared. PC is square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared, plus AC squared. AC is 2 times square root of 3, therefore AC squared is 2 times square root of 3 squared. In conclusion, found out that x squared equals to the square root of 6 minus 1 squared plus 2 times square root of 3 squared. So x squared equals to, here we open the brackets according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. Therefore, square root of 6 minus 1 squared will be equal to the square root of 6 squared, that is 6, plus 1 squared, that is 1, minus 2 times square root of 6 times 1. And 2 times square root of 3 squared, it is 2 squared, that is 4, times square root of 3 squared, that is 3. And 4 times 3 is 12. In conclusion, found out that x squared equals to 6 plus 1 minus 2 times square root of 6 plus 12. So x squared equals to 6 plus 1 is 7, minus 2 times square root of 6 plus 12. 7 plus 12 is 19, so in conclusion, found out that x squared equals to 19 minus 2 times square root of 6 units. Here we took a root out of this equation and found out that x, the line segment that we are looking for, it is equals to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, it is equal to 3.755 units. So this line segment x equals to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, AP that is equal to x equals to 3.755 units. Okay, thank you very much.